9 planets orbit an average-sized star in the Milky Way galaxy, the Sun. The third planet in the solar system is Earth. Our closest neighbors, Venus and Mars, are the most similar to Earth, yet a closer look reveals they are very different worlds. Venus is closest to Earth in size, mass, and gravity, but it has a dense atmosphere of carbon dioxide, and there's almost no water. The surface of Venus is extremely hot, with an average temperature of over 800 degrees Fahrenheit. Mars is about half the size of Earth and has only a thin atmosphere. Its surface is cold, with temperatures falling to minus 190 degrees Fahrenheit. Water is frozen at its poles and possibly under its surface. Our Earth is unique among the planets. Liquid water covers 70% of the surface, and the atmosphere is rich in water vapor. It is a geologically active planet, yet Earth's most unique characteristic is the presence and diversity of life. Spacecraft and satellites that image Earth have forever changed our view of the planet. We now see Earth's oceans, land, atmosphere, and life as interconnected global systems. The Earth is bathed in energy from the sun. The oceans, land, and atmosphere absorb and are heated by this energy. The heat absorbed by the oceans and transported by its currents is constantly released into the atmosphere. Heat and moisture from the oceans drive atmospheric circulation and weather patterns. Moisture in the atmosphere forms clouds, which cover an average of 40% of the Earth at any given time. The patterns in cloud motion in this time-lapse sequence show how Earth's winds move in bands or zones, which define regional wind directions. The movement of moisture or water vapor in the atmosphere is important in determining the weather. In the swirling motion of atmospheric water vapor, the hurricanes of 1995 can be seen. The hurricanes form off the coast of Africa and move west across the Atlantic to the Caribbean and the east coast of the United States. Our global climate is also influenced by the way heat is distributed in Earth's oceans. Changes in sea surface temperature over a 9-year period are shown here. The warmest surface water is indicated in red and the coldest in blue. With such data, it is possible to detect the anomalous increase in temperature that occurs when the normally cool water of the Eastern Pacific is replaced by warmer water. This phenomenon is known as an El Niño. An El Niño can disrupt climate on a global scale, causing widespread droughts and floods. Draining the oceans reveals that the Earth's solid surface, its crust, is divided into highlands and lowlands. The highlands are the land masses that form the continents, and the lowlands form the ocean basins. The Earth's crust is not a fixed, continuous shell. It is broken into a mosaic of moving plates. As these plates move and shift against one another, they release enormous amounts of energy in the form of earthquakes. The yellow dots show the locations of earthquakes that occurred from 1980 to 1995 with magnitudes greater than 4.5 on the Richter scale. These earthquakes clearly mark the boundaries of the Earth's plates. As oceanic plates are driven under continental plates into Earth's mantle, they begin to melt. The molten rock rises to the surface, forming volcanoes. The red triangles show the locations of recorded volcanic eruptions that occurred from 1960 to 1995. Like earthquakes, most volcanoes are located near plate boundaries. The oceans, atmosphere, and land all play critical roles in sustaining life on Earth. The characteristics of ocean currents, wind patterns, and topography can make one area a desert and another a rainforest. Seasonal changes greatly affect Earth's plant life or vegetation. The shades of green and yellow show how leaf-bearing plants green up and decline through the seasons of the year. The vast deserts of North Africa, the Arabian Peninsula, and Central Asia are easily recognized because of the lack of vegetation. The influence humans have had on the Earth can also be seen from space. Viewing the Earth at night, we see the light of countless villages, towns, and cities pour into space. Major population centers, shown in white, are prominent sources of light. Fires from slash and burn farming and burn-off of natural gas in oil fields are shown in red and yellow. From this perspective, the scale of human activity on the Earth can be appreciated. It spans the globe. Global monitoring of the Earth is helping us to understand the complex interactions between the atmosphere, oceans, and land, and their impact on life. Only through a global view can we truly appreciate our Earth as a planet.